All right, so here we got our twin for your last test of Algebra 2. All right, let's start off this one here by doing what good test takers do, and if they're intrigued, they draw a triangle. Notice how I orient. The sine ratio is opposite over hypotenuse, so opposite of theta is a 3, hypotenuse of 8. To get the tangent ratio, I kind of got to know what this guy is, because I need opposite over adjacent, right? So I'm going to do some old theorem here. It says a squared plus 3 squared is 8 squared. Of course, 8 squared is 64, 3 squared is 9, 64 minus 9, I'm pretty sure is 55. I know you don't believe me, like, wow, apparently that's a lot, but let's check me because it is early in the morning. 8 squared minus 3 squared, I bet it's 55. And it is. That means that a is simply the root of 55. All right, so now I'm going to do the tangent ratio. From SOHCAHTOA, which you can write all over your piece of paper if you wish to, the tangent of an angle is the opposite over the adjacent side. So I will have 3 over root 55, which is not a valid answer. And numerically, it's correct. But we need to clean it up. We're going to multiply the top and bottom by root 55. And that's going to give us 3 roots of 55, and a root 55 times root 55 is 55. All right, number 2, given that the sine of beta is root 33 over 6, and the cosine of beta is negative root 3 over 6, find the tangent of beta. So remember, this is the opposite over hypotenuse ratio, and this is the adjacent over hypotenuse ratio. And we're just going to put beta at the origin. Opposite would be root 33. Hypotenuse is 6. Oh, wait a second here. Look at this. The cosine ratio is negative. This triangle isn't where we think it is it? Start over here. Little ASTC. Sine is positive, but cosine is negative. So sine is positive here, but cosine is negative. This is where the triangle lies. Beta prime would be right there. Anyways, cosine is adjacent, so negative root 3, I did adjacent over hypotenuse here. Hypotenuse is 6. Sine is opposite over hypotenuse, root 33 right there. Got to be careful about things, all right? So anyways, let's do our tangent ratio here. The tangent ratio would be opposite over adjacent. So tangent of beta would be root 33 over a negative root 3. We can think of this as a negative root of 33 over 3, which is a negative root of 11. All right, number 3, angle alpha, drawn in standard position, intersects a circle with a radius of 8 at the point root 39, negative 5. Find the secant of alpha. So you're supposed to know your circular approach to trigonometry. And the secant ratio on a circle is the radius over x. Well, there's r, there's x. So the secant of alpha is simply 8 over root 39. And we clean that up by multiplying both the numerator and denominator by root 39. And 8 times root 39 is 8 root 39. And a root 39 times root 39 is simply a root of 30. Sorry, I don't know why I put the root key there. Is simply 39. First 3 are pretty easy. We'll see how that goes. Number 4, a theta being drawn in standard position intersects the unit circle, which has a radius of 1 at negative 1 over 4 and negative root 15 over 4. Evaluate the sine, cosine, and tangent of the angle. All right, so it should be a pretty easy problem here. The sine ratio is just going to be y over r, which is going to be negative root 15 over 4, all over 1, which is just negative root 15 over 4, because we're dividing by 1. On the unit circle, psi is y. Cosine on a unit circle, or any circle, is x over r, which is just negative 1/4, because you're dividing by 1. And then, of course, tangent on a circle is going to be y over x. And this will be, the tough one, I guess. We have a negative root 15 over 4 sitting pretty over a negative 1 over 4. The 4's cancel, the negatives cancel, and we're left with root 15. All right, number 5, standing on a building 2,200 foot tall, you look down at a car. If the angle of depression to the car is 68 degrees, how far is the car from the building? So you're on top of a building, looking down at a car. The angle of depression is formed with the horizon. Should probably type some stuff out here for you so you can maybe have a chance at remembering this stuff. But the angle of depression is formed with the horizon, and it is congruent to the angle of elevation that is formed with the ground. So even though this 68 degrees doesn't lie inside the triangle here, it is congruent to the angle of elevation down below. The building is 2,200 foot tall. I want to know how far the car is from the building. So if I think about my relationships here, this is opposite and this is adjacent of this 68 degree angle. That's the tangent ratio all day long. The tangent of 68 degrees must be 2,200 over x. 2 moves before you go to a calculator. First move, multiply both sides by x to get her out of the denominator. So x tangents of 68 degrees is equal to 2,200. Remember, we're playing the isolation game here. Some of you guys have been in Algebra 2 for 9 months, still can't do two-step equations. Next move, divide both sides by the tangent of 68 degrees. And Cantrell and Garner were complaining that we couldn't do two-step equations either. Like, it's 2 steps. It's not that hard. Now, anyways, on test day, make sure that you press that mode key and make sure you're in degree mode and not radian mode, not unless you need to. So we got 2,200 sitting pretty over the tangent of 68 degrees, and we get about 888.86. So I'm going to round that to the nearest foot. It's about 889 foot. Moving forward with my life, don't know about yours. I'm moving on to number 6. Convert negative 2.49 radians into a degree. To convert a radian into a degree, you multiply by 180 degrees over pi. So I'm going to take my negative 2.49, and you should write this because that's going to help you remember it. Or, don't. I'm hoping y'all will pull it together, even though you don't want to. Negative 142.67 degrees. Easy. Peasy. Lemon squeezy. Number 7, evaluate the cotangent of 5 pi. This cannot be done with triangles because of where 5 pi is. You may or may not get this, but coterminality means you can take away multiples of 2 pi. So the cotangent of 5 pi is actually equal to the cotangent of pi. You're allowed to take away circles, all right? Called coterminality. All right, so I am visualizing a unit circle here, and this is where pi is, right? 180 degrees. Order of pair there is negative 1, 0. You think about your circle quizzes here. The cotangent of theta is x over y. So I have an x value of negative 1, and that's an over y value of 0. And this is undefined all day long. All day long, that's undefined. Now here's something for you guys, if that's just too much. That was a pi rad, so I'm going to hit mode. I'm going to go back to radians. And to some degree, you can do this on a calculator. Cotangent is the reciprocal of tangent. So I can do 1 divided by the tangent of 5 pi. That's what I can do. And it has error divided by 0, which is, of course, undefined. All right, find two angles coterminal with 11 degrees. All you do is you add / subtract 360 degrees. And this will be a multiple select. It will be. It'll be a multiple select problem. All right, nothing, it's just the way I wrote this one. But, you know, if you add 360, you'd be sitting at what, 371 degrees? Or you could add 360 again, and you'd be sitting at 671. Lost my train of thought here. 731. You could just keep going all day long. You could also take away 360. First one would be negative 349 degrees, and you could take away 360 again. And you'd be looking at what, negative 700, and had it lost at 11? That seems wrong. 51, 9. Lots and lots of things you can do. All right, which two angles are coterminal with 21 pi over 4? And the deal here is we add or subtract multiples of 2 pi. It's about plus or minusing twice pi. So let's stay old school, because old school is the best school. 21 pi over 4, add 2 pi. Now think about that. If you're going to add 2 pi, you know, your 5th grade math teacher taught you that you have to have a common denominator. So what we're doing is we're going to change this into 8 pi over 4. And 21 plus 8 is 29. Now, if I was to add another 8 pi over 4, I'd have 37. That's how it works. And I'm not going any higher. If I look at this, I don't see anything higher than 37, so I'm not going to bother adding 2 pi anymore. Other way around here would be to take your 21 pi over 4 and take away 2 pi, which is also known as 8 pi over 4. 21 minus 8 is 13, which isn't showing up, right? I don't see it. So let's take it away again. And 13 minus 8, I feel like that's 5. And by golly gee, wow, it is. And those are your answer choices. So again, for those of you who are, let's go with mentally challenged here. I just type in the fraction without the pi key, kids. Watch this, 21 over 4 plus 2. Math, enter, enter. There's 29. Add 2 again. They'll probably keep it as a fraction. There's 37. All right, let's go the other way around. We got 21 over 4, take away 2. This should be the 13 that I had earlier. We'll find out if I was doing things right. And it was, but it's not there. So I'm going to probably take away 2 again. And there's the other one. All right. Number 10, using reference angles and the 30, 60, 90 pattern, evaluate the cosecant of 11 pi over 3. Now, what you're going to want to do first is you're probably going to want to make this thing a degree. You know, pi is worth 180 degrees. And say that you don't look at that and know it's 660. Just bless you. It is. You just push buttons in the calculator. So what you're actually working with here is the cosecant of 660 degrees. Now, because of coterminality, you are allowed to take away multiples of 360. Because you can always go full circle and just same spot, so just take the circle away. So what you're actually dealing with here is a 300-degree angle, and there's lots and lots of ways of doing this, okay? You could even just cheat with your unit circle if you wanted to. You could cheat with unit circle. You could. But 300 degrees is going to rotate, well, to about right there. All right, now reference angles is a big thing. Trig is built on reference angles and 30, 60, 90 patterns. So if you rotated 300 degrees, that means there is 60 degrees of rotation left. And that's your reference angle. Now, if we think about some 30, 60, 90 patterns that Milbrath has asked you to memorize, opposite of a 30 is a 1, hypotenuse is 2, opposite of 60 degrees is a root 3. There is a root 3 here, but she's falling, so she's negative. A 1 here, and a 2 here. Hypotenuses are always positive because they're actually about a concept of magnitude as opposed to distance, or sorry, as opposed to direction. Anywho, there's my 30, 60, 90 pattern. The cosecant ratio is Santa Claus's favorite ratio, right? What's Santa Claus say? Santa Claus says, ho, ho, ho. So hypotenuse over opposite, we get 2 over negative root 3. We clean that up by multiplying the numerator and the denominator by a root of 3, and we get negative 2 roots of 3 over 3. All right, so check this out. Let's type that in. Just showing you how to possibly cheat. All depends if I make the question multiple choice or not. I probably won't, to be honest with you. But you can check your answer, all right? I got negative 2 root 3 over 3. I'm going to put my calculator in radian mode, and it is already. And I don't have a cosecant button, but I have a sine button, don't I? So I can do 1 divided by the sine of 11 pi over 3. And there is that decimal, so I know I did my work right. Right, I'm probably going to do these two and I'm going to stop this video. Using reference angles and the 45, 45, 90 pattern, evaluate the cosine of 21 pi over 4. So let's take that 21 pi over 4, replace the pi with 180, make her a degree, and we get 945 degrees. Now we can take away 360 from that bad boy twice. You don't know there's 720 degrees in 2 circles, just take away 360 twice. And you get the cosine of 225 degrees. Now, I don't know that you actually needed reference angles. I mean, I'll talk about that here too. May as well. But anyways, a rotation of 225 degrees rotates through quadrant 1, quadrant 2, and halfway into quadrant 3. The angle formed with the nearest x-axis was 45 degrees of rotation. One of the 45, 45, 90 patterns that you were taught is 1, 1, root 2. 1, 1, that one's negative. Hypotenuse is always positive. Now, using reference angles, cosine is going to be the adjacent over the hypotenuse. So it turns out that the cosine of 225 is negative 1 because it's running left. I almost made a mistake there, over the hypotenuse of root 2. Now, you'll notice I almost made a mistake here. All schools tortured children. Only tangent and cotangent are positive in that quadrant, so the cosine ratio is supposed to be negative. Anywho, clean up that number, multiply the top and bottom by root 2, and we get negative root 2 over 2. Now, I mentioned the unit circle. Now, here's 225 degrees. The ordered pair there is negative root 2 over negative root 2 over 2. I said that backwards, but negative root 2 over 2, negative root 2 over 2. And on the unit circle, cosine of an angle is the x-coordinate. By God, you'll see that they match. Other things for those of us who are mentally challenged, it's just my calculator's in radian mode here. Some days I too am mentally challenged. I kind of feel like today is going to turn into one of those days. I get negative 0.7071. All right, cool. Well, guess what negative root 2 over 2 is? I bet you it's the same blasted thing. It is. Wow. Mind blown. Moving forward, number 12 is where I stop this video. Using reference angles and the Z30, 60, 90 pattern, evaluate the sine of a negative 120 degree angle. That is going to rotate like a clock. If you don't know how a clock rotates, look at a clock. Just don't be the kid who looks at the hour hand. You're going to be there a while before you figure it out, but you're probably a little slow anyways. So yeah, look at the hour hand. Go for it. We're going to rotate like that. And I'm being sarcastic, kids. You know I love you, by the way. That's what a negative 120 degree angle looks like. It has 60 degrees of rotation left to get to the x-axis because that's what reference angles are. And of course, by 30, 60, 90 pattern, opposite of a 60-degree angle is a root 3, negative because she's falling. Adjacent to a 60-degree angle is a 1, negative because she's running left. And the hypotenuse is twice the short leg, so 2. And I want the sine ratio, and the sine is opposite over hypotenuse. So opposite of this reference angle is a negative root 3, and the hypotenuse is 2. And again, check this out. Watch this. I go to mode. I go to degree. I type sine negative 120. I get a decimal. Is it the same thing? Is it? Well, yes, it is. And that's where I stop for right now. I'll do another video here in a little bit, but I'm tired. I don't want to do anymore. Plus, it's like a week and a day ahead.